So, before I start, I want to introduce myself. You probably already know me. My name is Liliane Hofer, and I'm working at the Central Institute for Meteorology and Geodynamics in Austria. But I'm not sitting in the headquarters in Vienna, but I'm located here at the regional office in Salzburg. And now I would like you to take the star and put it to where you are at the moment so that we get an overview. Okay, so I think that's it. Thank you. So now here's my outline for my talk today. So first I will talk about a distinct phone episode in the Alps during the Christmas holidays. Then secondly, I want to deal with the topic, where is the winter at the moment? Because over here in Austria, and I think in most parts of Europe, it's more spring than winter at the moment. And in the end, we will take a look at the actual weather situation. But now we will start with Christmas, or at least with the weather situation we had during the Christmas holidays. You can see here the air mass RGB on December the 24th, 12 UTC. You can see a distinct trough over the Atlantic, transporting cold air over the Atlantic, resulting in these showers you can see over here. We can see this frontal system here, some wave developments, and there's also a frontal system over here. As you can see, the air mass RGB shows us with what air masses we have to deal. So the cold air masses, the polar air masses, are more on this side, on the northern half of this image, and the warmer air masses you can see in these green to orange colors are restricted to the southern half of this image. And now, just as a small warm-up question, I would like you to take your pencil, take a star, and put it to where you think that the jet stream is located at the moment. Just as a little warm-up question, so just put your star and... Okay, looks quite nice now. Okay. I will give you another few seconds before I will show to you the solution on the next slide. Okay. So here we can see the jet. So I think you were mostly correct. So it was in front of the warm front or behind the cold front here. In front of the warm front here. Here we have the subtropical jet stream, and this what you can see here is just a stripe of dry air, and it's not a jet stream, although it can be, yeah, it looks a little bit like that, but it was a small trap there. Okay, so it's again December 24th. This time it's the infrared satellite image overlaid with the mean sea level pressure, and I want you to concentrate on this region over here, the Alpine ridge, because you see a really distinct pressure gradient over here. And I'm not sure whether you have heard of the wind phenomenon föhn. It's an orographically induced wind system, and winds like that can occur on every mountain range as long as the flow is perpendicular to it. So in this situation we have a southerly to southwesterly stream, and the Alpine ridge is kind of a barrier to the stream, and so on the southern side the flow slows down, and therefore the air column gets a little bit heavier, thicker over here. The pressure is rising, and on the other side, when the flow comes across the Alpine ridge, it is accelerated, and therefore the pressure drops. So we have this pressure gradient resulting in the wind, but also responsible for the wind. And such wind system can occur, as I said before, at every mountain range. Here in Austria we call it föhn, and it mainly brings heavy clouds at the southern side of the Alps and rather sunny conditions and warm temperatures on the northern side of the Alps. And as you can see, we have here a pressure gradient of about 15 hectopascal. And we will now take a look at a station. It's the so-called Portugal. And if you take a look at the wind, which is this yellow line, you can see that the wind is really, the velocity is really rising throughout the day, and in the evening we have values of about 170 kilometers per hour, just because of the pressure gradient and just because of the southwesterly flow. I have to admit that Portugal is a mountain station, so its elevation is 2,200 meters, but nevertheless gusts of 170 kilometers per hour, that's just enormous. And how does the pressure gradient look like? Because we've just seen the model data, and there you see the analysis of the phenomenon, and you can again clearly see this pressure gradient of about 15 or even 20 hectopascals, depending on where you start to count. But yeah, that's really typical for föhn conditions. And you can also see the frontal zone over here, which is kind of slowed down by this wind phenomenon, as you will see in the next slides. Until now, we have just seen the föhn in the weather data, in the model data, but not in the satellite images. But 12 hours later, on December 25th at 6 UTC, we can also detect the föhn in the satellite image. I've chosen here the Hermes RGB because it's best visible in this image at that moment. And you can clearly see this this lee cloudiness over here. So the air is lifted and it's really moist, and therefore this cloud pattern here establishes. And that's a typical satellite image for a föhn condition like that. But during the Christmas holidays, föhn was really dynamic, so all the time it shifted and changed, and so really different satellite images formed, so to say. So if you just take a look 2 hours later, we have here a really wonderful example for a lee wave cloud and this arc-shaped back end cloud over here. So the air is lifted when it comes across the alpine ridge, and then depending on humidity it forms these clouds, and depending on the streaming pattern. And at this moment at 8 UTC we had this kind of beautiful föhn gap, bringing lots of sunshine to the southern parts and heavy clouds to the northern parts. What you can also see here is that here seems to be less humidity, as there are less clouds than here. And yeah, it's a really nice example for this phenomenon. And as I've mentioned before, the cloud patterns were changing really fast on this day, and now we have also föhn gap on the northern side of the Alps. So you see this nearly cloud-free area over here, but I now want you to concentrate on this special cloud pattern. It's also a kind of a lee cloud that established south of the city of Salzburg. And what I think is most interesting, that normally in the Hermes RGB the clouds are white or dirty white to yellowish, and in this case the clouds are more cyan, or have more a cyan color. So I'm not quite sure why this is, but it's, yeah, at least it highlights this feature, which was very interesting on that day. So, but now we'll take a look again at the overall weather pattern. So we had this frontal zone over here. You see that we have some kind of a wave development over here. Here seems to be a low pressure system, and the föhn holds back the frontal zone from advancing. So we have in these regions over here lots of clouds and heavy precipitation, whereas we have mild temperatures and mainly dry conditions over here. So föhn brings not only sharp pressure gradients, but also sharp weather gradients, so to say. And if you take a really close look, you can also at this time at 8 UTC, you can see the bluish cyan clouds also somewhere here. I don't know if you see it that good, but it's still visible, this orographic Lee cloudiness. So December 25th was a really special day for this area affected by föhn or affected by the frontal zone. So in Salzburg, we nearly measured a temperature record for December. So we reached 19 degrees on this day, which is really, really hot for this area. And it is nearly the same temperatures were present in Greece or somewhere more south. So it's really exceptional, this temperature. As mentioned before, we had wind gusts up to 177 kilometers per hour in upper regions. So, but we also had heavy wind gusts in the valleys, for example, 95 kilometers per hour in Innsbruck, which is really lower. But we also had heavy rain and snowfall. So in the Canton Ticino, in regions higher than 1,000 meters, they got 120 to 150 centimeters of snow in 24 hours. And that's also partly because the frontal zone could not get forward. It was kind of stationary, also due to the föhn conditions. Okay, so that's it for this föhn episode. I hope you gained a nice insight into it, and I'm sure in your region there will be similar wind phenomena if you have mountain ranges. And the mountain ranges do not have to be that pronounced, but then the phenomenon is not that heavy as in Austria in this example. So now we will take a look at this question. Where is the winter at the moment? As I've said, we had 19 degrees during Christmas holidays in Austria. So at least in the northern parts of Austria, winter has not begun so far. So I want to ask you, I want you to take a look out of your window and just tell me whether you see snow on the ground or not. Just take your star and put it where you want to. And we also have a third option, and know with a star. So if you do not see snow on the ground, but on near mountain regions, you can put your star there, as I will do it. Okay, so I'll give you some more seconds. So most of you don't see snow on the ground, just as I suspected it would be. But now we will take a look with the help of satellite images where the winter is at the moment, or was. So a big no I can see there. Okay, now we will look for the snow. You have probably heard of this episode of this winter storm, which occurred in the beginning of December in the Middle East, and I have here a satellite image that was taken after the clouds of the storm have cleared. It was taken by NASA's Terra satellite on December the 15th, and you can clearly see the snow in the Middle East in these regions. And this snow is mainly confined to higher elevations, but also Jerusalem got lots of snow. They had 30 to 50 centimeters, and that's quite a lot. I mean, winter storms are not unknown in this region, but not common either. But this winter storm in the beginning from December was comparatively early and intense storm for this region. So yeah, that's the first hotspot for the winter this year. And then I'm sure you have all heard of the polar vortex and the really low temperatures the US and Canada suffered from. And this is a satellite image again taken from NASA's Terra satellite. And you see the Great Lakes, and it's a RGB composite. So this bright orange color depicts snow, this dirty whitish color snow clouds, and this peach color mixed clouds. And you can see lots of snow here in the surroundings. And what I want to concentrate on is this steam fog that forms over the lakes, because the cold and dry air comes from northern directions, and as it crosses the comparatively warm and moist lakes, fog forms, and in this particular example, so-called steam fog forms, and you can see how it moves in that direction. And now we have seen the steam fog from above, and I will show you now how it looks like from the ground. That's how steam fog looks like, and if you take a look at this website, you can also see some nice videos, and it really looks breathtaking, although it's probably not that nice for the people who live there, but at least it looks really beautiful. It looks like the lake is boiling or something like that. And you've probably all seen these pictures of the Niagara Falls, which are partly iced over. I mean, they've not frozen completely, but at least partly. And they're also a sign for the really cold conditions they suffered from in the western parts of the US and in the western parts of Canada. And it was really exceptional cold over there. And now, just some days later, we will again take a look at the Great Lakes, this time in particular at the Lake Erie. And we can see here an image taken by NASA's Aqua satellite, and you can see that most parts of the lake are frozen. And okay, it's normal that the lake is frozen in January, but this time the ice cover seems to be thicker and more widespread than it has been in nearly 2 decades. And it's also hampering the ship traffic. So although it looks quite beautiful on this satellite image, it's not that nice for the people who live there. There's only one positive side effect, if you want to say so. The normally really persistent lake effect storm that brings much of snow is absent, that there is no source for moisture at the moment as the lake is frozen. So that's only one positive side effect. But now, as I've told you, meanwhile in Austria it looks like this. At least in the northern parts. I mean, in the southern parts we have more snow, we have heavy snow, but here you can see the snow cannons, and they just try to, yeah, get some snow for the skiing slopes. And let's take a look where the winter really is. I've just taken these weather maps from the GFS model, as they are available in the internet, so everybody can take a look at them. I mean, we have similar weather charts at the ePort when you take the polar ePort, but the colors are not that good visible, so I've chosen this one over here. And if you take a look at the colors, which depict the geopotential height in 500 hectopascal, you can see a distinct trough over the western part, over the eastern part of the US, and also a distinct trough over here. And when it comes to Europe, it's more undulating, so we have trough, more ridge and things like that, but we still seem to have this persistent southwesterly flowing pattern there. You can also take a look at this low pressure system, as I'd like to concentrate on then later on, but first we will also take a look at the temperature in 850 hectopascal. It's still this northern hemisphere chart, and you can see that the cold air is concentrated over Siberia, as it should be at this time of year, but also still over the western parts of North America. And when we take a closer look at Europe, we see it seems to be cold over Scandinavia, but as you look more south, it's really warm, so freezing level somewhere here, and that's clearly not normal for this time of year. But now let's take a look at the actual weather situation. Probably winter will come soon. We will now take a look at it. You have here the infrared image from yesterday, 12 UTC, and of note is probably this frontal system over here with cold front and warm front. We have a frontal system over here, kind of like that. And of note is probably this peculiar gap here, this cloud-free area between the cold front and the warm sector. And yeah, before we take a closer look at it, what it is, I would like to take a look at the pseudo-infrared image. That means the model satellite image, and we will see whether the model has predicted this cloud-free gap. And you see the model is quite good in that case. So we have the gap over here. That seems to be predicted correctly by the model, by the ECMWF model. What more can we highlight? We have this, sorry, that's too fast. We have this pattern over here forecasted. We have this arc-shaped cloud. Also in the model, if you look at these two features, you can also find them here. We have here this shape and there this arc. And yeah, so model satellite images are not too bad. They seem to work really good, although they probably not always have the features where they should be. And they can also be a quick help whether the model is right or wrong. And you can also find them in ePort if you haven't known that by now. Now we will take a closer look at this gap, as I have promised in the beginning. You see here the equivalent thickness, and this cloud band is clearly the cold front, as you can see on the isobars of the temperature. And here we have kind of a tongue of warmer air, which seems to be responsible for this cloud-free area. And what more can we see on this air mass RGB image? Of notice probably also the greenish area you can see over Greenland, and also here. And that's not a sign for air mass, but more a sign for the temperature conditions on the ground, because on the green beam in the air mass RGB we have the more or less the temperature of the ozone in the tropopause and the temperature of the ground, because the IR 9.7 and the IR 10.8 are used for the green beam. And if the ground is as cold as the ozone layer, so to say, the green beam gets a really large contribution, and therefore we get this greenish shimmer if it's really cold on the ground. And now I want you to take again your star, and we will again look for the jet stream, just as we did in the warm-up question. So just take your star, take a pencil, and show me where you think that the jet stream is located in that image. Okay. Looks to me you had quite some ideas. Now we will take a look at the solution of this question. And so if I toddle a bit back and forth, you can see you were right in nearly all cases. This is not a jet stream. This seems to be just a drier air. And only one highlighted this area, which I would like to concentrate on now. As you can see here, a branch of the subtropical jet stream. We have this really typical cloud that appear in combination with that. But in order to see them a little bit more pronounced, we will now take a look at the water vapor image. And what you can see here on this edge of the image are so-called transverse cloud bands that are substructures in high-level cirrus clouds accompanying the subtropical jet stream. And these fiber clouds are orientated perpendicular to the jet stream. So the jet stream is this, and the cloud streets are perpendicular to it. And you can sometimes see them in combination with the subtropical jet axis. And this is really a nice example for them. But now we will head back to our frontal system, or we will concentrate on the frontal system. It's now January the 16th. 6 year to see this image. You see that the frontal zone has weakened a little bit. We have some wave developments over here, but it doesn't look that organized at some hours before, and it's probably because a major ridge is situated over here blocking this pattern, so it has weakened. Won't bring that much precipitation, at least to Middle Europe anymore. And we can also see that our transverse cloud bands have diminished. But what we don't see in this image, or what we don't see that pronounced in that image, and what is always a reason for using RGBs, is that they highlight special features, and in this case they highlight the fog. So I will toggle now back and forth so you can see the difference, and I want you to concentrate on this area, as in this night RGB image, this yellowish color depicts the fog on the ground or the low clouds. And if I toggle back and forth, you can, you can't really see the low clouds over here, but they're really pronounced in this RGB image. So never forget, if you have a situation like we have now, that means high pressure over here, nearly cloud-free nights, much moisture in the boundary layer, then the fog is likely to form, and you can see them best in special RGB products, like in this example, the night RGB. And what you can always do if you have such a satellite image, you can compare it to the model fields and see whether the model is good or bad at locating the fog. And I will now overlay it with the ECMWF field of the low cloud coverage. And you see that the model seems to be really good in this area, but doesn't seem to work that good in this area. Probably the fog is not thick enough so that it can be detected by the satellite. You never know, but there doesn't seem to be fog. The model is quite okay in this area, although it doesn't have this fog located correctly. But otherwise, model field seems to be really good. And fog prediction is a really tricky problem, so you cannot always count on the models, but in this case, yeah, the performance was not too bad. Yeah, and to the question where the winter is at the moment, I will now answer it, at least for the for Central Europe or for Austria, because in the weekend again we will have this southwesterly stream, which will mean firm conditions in the Alpine region, and I think because of this southwesterly flow, the weather will be more mild than wintry in most parts of Central and also Western Europe. But I'm sure winter will come sooner or later this year. And with this last image, it was taken at the headquarters of the Central Institute for Meteorology and Geodynamics. I want to say thank you